Dear students, I am continuing from the last point which I have discussed in the last session. It is about the duration of a single time slot is 0.577 milliseconds. Just give a look here at the bottom of the screen. There it has mentioned, it has shown the 8 total users. It is there in one time division multiple access frame. For one user, this is user 1, 2, 3, so 0 to 7. Out of that, if any user, if I have to understand, for one user, the detailing of the bits and the timing, it is given over here. So one user with 156.25 bits, it is going to take 0.576 milliseconds time. So such a one user time, if I multiply by 8 such time slots, I am going to get 4.615 milliseconds, and that is what is mentioned here. Therefore, each TDMA frame repeats every 4.61 milliseconds. These time slots are known as physical channels. So these are nothing but called as physical channels. Within each time slot, a radio burst is transmitted. We will see this burst, GSM burst, in later few sessions. But burst is nothing but a bit sequences that are generated. This burst comprise 156.25 bits periods. Therefore, a frame comprise 8 into 156.25, which is nothing but 1250 bits period. If a frame is transmitted every 4.615 milliseconds, the raw data rate over the carrier channel is, we can say, 1 divided by 4.615 milliseconds into the total number of bit 1250, which gives us 270 kbps. You have to understand and remember this figure 270 kbps. So this 270 kbps is the ultimate bit that is get transmitted after the modulation done on the bit or the information given by user. The corresponding physical raw data rate is 270. If I divide it per user, or you can say 8 total time slot, then for per user we can say 33.75 kbps. So this is the total bit sequence that we can get for one single user. In continuation with, in few slides we will understand it much better. So you have to remember 270 kbps data sequence. So here also you can understand radio interface bit rate is 270.8 around kbps. This is what is the signal processing is used in GSM. So we can understand through this figure, like when I'm talking into the mobile phone, the speech, it is analog signal. When it enters into the mobile phone, then all digitization techniques will be carrying analog signal into the bit sequences. So speech signal is then converted into the speech coding, and the coder that is used is regular pulse excited long term prediction, RPELT. This is what is the coding that technique that is used, that will convert it into 13 kbps. Then there will be channel coding, which is taking care of error protection, CRC. And after that, the data sequence, it is converted into 22.8 kbps. Then it is going to have a interleaving that is going to control the minimum sudden fades that appears if it is into it. Then interleaving, that changing the bit sequences and all, so it is maintaining 22.8 kbps. Then burst formatting, it is getting done into it to synchronize and equalization. After that, it is converted into the 33.6 kbps. So the speed is the after speech processing or the signal processing, that speed is basically managed with 33.6 kbps, which will be, you can correlate with the previous slide where the time frame you can observe. And after ciphering, putting the security and encryption algorithm, that it is again maintaining the same 33.6 kbps, and the modulation it will be done with GMSK, Gaussian minimum shift keying. So we can say after the modulation of all the 8 users, that means one time frame, the radio interface will have 270.8 kbps data. This is what is how it is encoding the thing, and when it is getting to the other end, it will be demodulation, then deciphering, bus formatting, deinterleaving, channel coding, and speech decoding, and ultimately the signal which you have transferred, it will be converted into the analog again. This is a general, we can say, the flow of speech processing. We can say the same things which I have explained in the previous slide, that can be integrated here again to understand it better. So it is a speech, then digitizing and source coding, getting 13 kbps, channel coding 22.8, then interleaving and ciphering in the one as it is maintaining the rate as 22.8 kbps. Then there will be the TDMA burst formatting, which is maintaining it again to the 33.8 kbps, and that 33.8 it will get modulated on GMSK, and the air interface will be ready with 270 kbps. This is what is the time frame hierarchy, you can say, rather burst and frames, that is used in the GSM TDMA technology. So dear students, you have to just focus first over here. This is what is the time one frame, which is comprising of 8 different users with different time slots. So user 1 over here, 2, like that, total 8 user can be accommodated over here. Right now you just give a look over here, there are different burst signals. We will discuss this burst signal in coming few slides later on, but there are 5 different bursts that you now just observed here: normal burst, then you can say frequency correction burst, synchronization burst, excess burst, and dummy burst. Burst is nothing but the data sequences or the bit sequences that are incorporated in one user's data time. So we know the one user data time we have seen in the last session is 0.577 milliseconds. So one time frame is 8 times, carrying 8 time slots. So there is a hierarchy. So this is one frame, TDMA frame. Such a 26 TDMA frames are used and 51 TDMA frames are used. Later on, these multi-frame, we can call this is 121. Such a 26 frame, we call that as a multi-frame, and such a 51 frames we can call multi-frames over here. There is a combination that is made over here later on, that is such a 51 and 26 total frames that are combined in such a way that these 20, you can see here, this 50, it is comprising these 26, and these 26 that are comprising here around 51 multi-frames, the multi-frames into it. So it is a combination. 51 is having having into it is 26, and 26 is having a combination with 51 TDMA frames. Particularly these are used for broadcast channel and traffic channels. So we can say one super frame is nothing but the combination, as I said, 51 such multi-frames with 26 frames, or we can say 26 multi-frames with 51 frames. So in its combination, we can say one super frame is equal to 1326 TDMA frames, which is going to take time duration around 6.12 seconds. And such 2048 super frames are becomes one hyperframe. So one hyperframe, it will take around 3 hours, 28 minutes and 53 seconds and few microseconds. So this is how the bit sequences that are get combined, and at the end hyperframe, superframe, and like superframe, and then it is converted into hyperframe, and the data bit burst sequences that can be transferred into the network. This is what the relation I was talking about. the relation between burst and the frames. So 26 TDMA frame, multi-frame, it is supported with the traffic channel, slow associated control channel, and fast associated control channel. This 51 TDMA frame, it is supported to the broadcast control channel and common control channel, standalone dedicated control channel, and slow associated control channel. So later on, when we will see the logical channels, there you can understand it much better way. This is what the hyperframe, superframe, and multiframe, which I was discussing in the last slide. So dear students, we will continue with the next session. Here I am signing out. Thank you.